All right, hello everybody. Today we're going to be talking about experimental and theoretical probability. So what I like to think of as experimental is if you're actually trying it and recording the results, and then theoretical is what theoretically should happen, what results you should get. And so experimental probability is based on repeated trials. Oops, I'm on eraser. Repeated trials of an experiment. Oops, I forgot the experiment. All right, so to find the probability of the event, we're gonna have it like we're gonna make a fraction. So on the top, it's gonna go the number of times the event occurs. And on the bottom goes the total number of trials. So on our first example, if we look at this first one, it says, the table shows the results of rolling a number cube 50 times to find the experimental probability of the event. So rolling a 3. So it'd be the probability of rolling a 3. So the number of times that event occurs. So rolling a 3 occurs 8 times. Out of, we rolled the number cube 50 times. So we're going to write it as a fraction, we're going to write it as a decimal, and we're going to write it as a percent. So take your calculator and you go 8 divided by 50, that gives you 0.16. And then if you move the decimal 2 times, that's going to give you 16%. All right, on the next one, rolling an odd on a number cube. So odd, so that would be 10, because 1, 3 is 8, and then 5 is 11. So 10 plus 8 plus 11 would give you 29. So the number of times the event occurs is 29, and again, the number of times that we rolled the cube was 50. So if you divide those two, you should get 0.58 or 58%. So again, so the number of times it occurs over the number of times that you ran the trial. All right, so theoretical probability, the quotient of the number of favorable outcomes and the number of possible outcomes. All the possible outcomes are equally likely. So the probability of this event, so the way you're going to set it up this time, is the number of favorable outcomes over the number of possible outcomes. I don't know why I didn't put a number sign on that one. Oh well. Okay, so what is the probability of choosing a vowel? So if I'm looking at this one over here, out of these things, what is the probability of choosing a vowel? So I have E, O, and E. So that's 3. So my number of favorable outcomes would be 3. And number of total outcomes, I have E, X, P, L, O, R, E. So I have 7 possible outcomes. So that goes on the bottom. Again, we're going to write it as a decimal. And if you look, it's a really long decimal, so I'm just going to round it. So 0.429 or 42.9%. Okay, so the probability of choosing the probability of randomly choosing an X. So there's only one X out of 7 letters. So again, that's another really long decimal. So if you round it, you'll get 0.143, which would also be 14.3%. Okay, comparing probabilities. So comparing experimental to theoretical. So the bar graph shows the results of rolling a number cube 300 times. Does the experimental probability of rolling an odd number, how does the experimental probability of rolling an odd number compare with the theoretical probability? So step 1, find the experimental probability of rolling an odd number. So if you remember, our probability was the number of times the events occur and then the total number of trials. So for rolling an odd on my thing, I had 48 times for 1, I had 50 times for 3, and then 49 for 5. So 48 plus 50 plus 49, that would give me 147. So I have 147 out of, and I rolled the number cube 300 times. So when I divide that out, that would give me 0.49, or, let's take an equal sign, it doesn't matter, 49%. So the theoretical probability, so to find the theoretical probability, I don't need to use this stuff up here. I know a number cube that has 1, 2, 3, 4, 5, 6. So on a number cube, it's 1, 2, 3, 4, 5, 6. Out of those that are odd, let me get out my highlighter. 1 is odd, 3 is odd, and 5 is odd. So that would be 3 out of all 6 numbers, which would give me 0.50, which would give me 50%. So if you notice, the experimental probability and the theoretical probability ended up being very close. All right, so using experimental probability. So a bag contains 50 marbles. You randomly draw a marble from the bag and record its color. Then you put it back. The table shows the results after 30 draws. Predicts the number of red marbles in the bag. So find the experimental probability of drawing a red marble. Okay, so we're going to take the experimental probability of red marble. So it occurred 9 times out of, I drew 30 draws, so I'm going to do 9 out of 30. Okay, and then if I wanted to divide that, 9 divided by 30 would give me 0.3, or 30%. Okay, to end up making the prediction, you're going to either have to use this one or this one when you multiply. So you're going to multiply. So they said there's 50 marbles in the bag. So you're going to take, you can either take 9 over 30 times 50, or you can take 0.3 times 50. Either way, you're going to get 15. And if you have any questions, don't hesitate to reach out. Assignment is on Big Ideas again. Have a fantastic day.